Hey class, welcome back. If you check out the notes behind me, we're doing the second half of week 15 here up on the notes, and I hope you're enjoying the little bits that we've been showing from The Martian right here. Don't tell Ridley Scott or 20th Century Fox that we're showing little bits of it on Zoom. I called and asked, but I never heard back from him, so I'm going to assume it's okay. So if you check out the little bits that we've been using from the motion picture version, a little bit different than the book version, we've been talking a little bit about comparing and contrasting the atmospheres of Mars and Earth. Remember, Earth has a wonderful layer of ozone that protects us from ultraviolet radiation, and the important thing is that life helps create our atmosphere. Life, especially bacteria and algae, which we'll talk about in just a second, helped put up free oxygen, which high in the atmosphere in the stratosphere makes ozone, protects us from UV light. Down here at the surface, O2, two oxygens stuck together, is what we breathe. Don't forget, as I grab the notes over here, to pick up and check out your copy of what should be in your notebook. These are out there at pacificascience.org and in your Google Classroom, so always make sure you're keeping up with that. So we talked about the 5 layers of the atmosphere on our Brain Pop. We also talked a little bit about something of an environmental success story. Sometimes when we're talking about things like extinctions and things like that in biology class, it can seem a little doom and gloom, but remember, collective action can do good things too, and this is one of those cases. The ozone layer, about the time that I was in 7th or 8th grade, scientists were starting to sound the alarm. They're saying the ozone layer is getting thinner, especially at the poles, North Pole and the South Pole. This was mainly because of CFCs, chlorofluorocarbons, basically chlorine compounds. We're using them a lot in refrigerants, things like car air conditioners and things like that. They go up into the stratosphere, they break down the ozone layer. A few chlorine molecules can do a number on thousands of ozone molecules. They can break them apart very quickly. The ozone hole, however, has been improving, getting smaller over the last couple of decades because countries get together and banned the use of CFCs. Now, they are still manufactured for some things, but overall their production has been greatly reduced, and the ozone layer is slowly building back up. This is a good thing. Ultraviolet rays are stopped by the ozone layer, so one of those things to check out. Another thing about the atmosphere that we saw, the different layers of the atmosphere have different characteristics. For example, the thermosphere has a layer in it called the ionosphere. Basically charged particles that hang out in the thermosphere. A lot of cool things. I remember, for example, being on a ride down to Los Angeles. So it's a weird tie-in, but things like radio signals can go up, bounce off the ionosphere, and go for miles at night. The ionosphere builds up again at night and it gets broken down during the day. And I remember being on the way to LA, the Giants, San Francisco Giants, were playing the Los Angeles Dodgers. My dad and I were listening to the radio, and all of a sudden, down near LA, we got KNBR out of San Francisco, clear as a bell. Why? Normally you wouldn't be able to hear KNBR way down there, but it was bouncing off, these radio waves were bouncing off the ionosphere and coming back down miles away. The ionosphere is responsible for a lot of cool things like that. Also check out, when you look at the notes, the layer that the Aurora Borealis and the Aurora Australis, I believe it's called, are seeing the northern and the southern lights. You can see those way up there in the mesosphere, so very, very cool stuff there. Moving on, we were talking a little bit about The Martian. In any good story, this is a little bit of an English tie-in here. You start with your protagonist, your hero of the story, getting into trouble usually right away, having some challenge to overcome, and usually at the midpoint of a story, there's yet another mountain to climb. There's something that goes wrong about halfway through a story. In The Martian, the movie version, they kind of set up NASA, the guy Teddy, played by Jeff Daniels, I believe, kind of as being the antagonist. Certainly they're trying to help Mark Watney, but he's not exactly nice about it sometimes. And in the story, as you can guess, spoiler warning here, and we see the habitat that he's in, break. And when that happens, the thin Martian atmosphere lets the water that's in those potato plants boil away. A lot of people think it gets flash frozen, but that's not quite the case. Remember, when there's very little atmospheric pressure, it can boil away very, very quickly because there's basically nothing holding in the water. It's kind of a way to think about it. Quick example here, when I was in 1999 taking 32 8th graders on a bus trip to Yosemite. A bunch of us stopped at Modesto to get a bunch of snacks for the rest of the ride to Yosemite. This was with St. Gregory School in San Mateo. And we picked up sandwiches and a lot of potato chips. Students who did not open their potato chips yet on the bus, as we drove into the higher elevations, as you move into the Sierra, you get up to about 6,000, 7,000 feet, they all notice, hey, our potato chip bags are expanding. What's going on? Well, you get thinner atmosphere, you get less dense air. The pressure inside the bag causes the bags to expand. Imagine then you go to a place like Mars and there's very, very little pressure. The water will essentially boil away. The water that doesn't boil away does freeze, and it sublimes after it falls to the ground as frost, and it will just basically sublime, which is a term for going straight to the gas state, kind of passing over the liquid state completely. So Mark Watney runs into a big problem, and they are trying to launch him. You might remember we hadn't quite got to that part in our story, but they try and launch him some protein cubes, basically candy bars, power bars. Why? Remember, he's got a problem with protein. He's got plants there. He's growing starches. He's growing carbohydrates. I'm sure they're going to launch him some of that too, but they were also going to try and launch him protein because us being omnivores, carnivores, we need animal protein or protein in the form of things like beans. It's hard. I myself don't eat very much meat at all, and you got to be. It's tricky to get enough protein if you're not a meat eater. You can do it. You just have to really watch your diet. So I eat a lot of beans and things like that, and milk will do it for you. In the movie, they're trying to launch him some protein to try and get him to survive for another, in the book, 2.5 years until the next mission arrives. Moving on, when we check out our atmosphere here on Earth, we have, again, in our notes, a little bit of a circle graph. The circle graph shows that most of our atmosphere is nitrogen, about 78% nitrogen. Remember, nitrogen is critically important for plants, but this gets back to the notes from earlier in the week. We can't use that nitrogen just by breathing it in. The plants can't just take it in through their stomata, through the leaves. They have to have bacteria fix or take the nitrogen from the air for them. This gets to symbiosis. This gets to the fact that on this planet, all of the kingdoms work together for life. Something doesn't live on an island. Again, getting back to the John Muir quote, things don't survive on their own. You can't look at one thing and just say, well, I'm just going to study this one thing. It's connected to everything else. In the case of life on this planet, the bacteria help the plants survive because the bacteria are busy taking the nitrogen out of the atmosphere for them, nitrogen fixing. That big slice of our pie, it's a little bit neater on the notes, but the big slice of our pie, that's oxygen. Again, that's up there because photosynthesizing bacteria and algae started to put this up into the atmosphere. And there was one big event we wanted to talk about. Make sure we get it down in our notes. And that was called the Cambrian explosion. Now, it wasn't a literal explosion. It's a figurative explosion. But around 500 million years ago, 518 million years ago, roughly, we think because the oxygen levels in the atmosphere were building up and building up, they finally got to a level that suddenly the animals started diversifying on land like never before. If you look at most of the phylum of animals on the planet now, almost all of them can trace their origin back to the Cambrian explosion 518 million years ago. Remember, if you were to step out of your time machine at any random point in Earth's history, chances are the most complicated life you'd see would be slime molds and algae. Big life, when I say big life on land, especially animals, didn't really start showing up until about 500 million years ago. I know that seems like a long time, but that's relatively recently when you consider that the Earth has been here for 4.5 billion years. And it's only in the last 500 million years that the party really got going. So that was important to talk about. And we also talked about the diversity since then, the kingdoms of life working together. Again, going back to last week's notes, in symbiosis. The fungi, the bacteria, they help plants survive. Plants, of course, are at the bottom of the food chain is the way we used to say it, but they're the producers in the food web on Earth. Very important to remember that all of life works together in a symbiotic web to help each other survive. Last little thing I wanted to throw in, this is not in your notes. I simply wanted to point out a couple of other things. So I'm going to the third screen. I don't think I've done this yet this year. For the Martian, just a couple things because one, you will see this stuff, especially when you get to 8th grade, and it's worth seeing. Again, not part of our notes. This will not be on the next test. The only thing that are on the test are the notes that are assigned in the pacificascience.org and in your Google Classroom. and the readings. But check out some of the other things you can talk about in this movie. One is Newton's laws of inertia, force, mass, and acceleration, and action, reaction. There's some great examples in this movie for it. Sometimes when I'm doing physics classes, we talk about, for example, inertia between Earth and Mars. The spaceship that they're on, the Hermes, you don't see like flames coming out of the back like you do with the the Millennium Falcon zipping off in Star Wars. Once the ship gets going, it has inertia. One of Newton's 3 laws of motion tells us that something will keep going in a straight line unless it's acted upon by an external force. Once you get it going between Earth and Mars or Mars and Earth, this ship just keeps going. Again, you have to fire your rockets occasionally just to adjust the course. But once it gets moving through space, you take a baseball in space and you throw it. Got my baseballs over there. I was going to use one as an example. It'll keep going at whatever speed you throw it until it's acted upon by some force. Force, mass, acceleration. The more mass something has, and the more force it has as it moves at a given speed. Again, great places in the movie to talk about that. Check these out for yourself. And then action, reaction. At one point, again, spoiler alert here, but at one point the ship, the Hermes, has to go back to get Mark. We are not up to that part yet. At this point, the Hermes is just headed home in the movie. But when they decide to go back to get Mark Watney, one of the ways that they slow down the ship is to let some air, some atmosphere out of the front of the ship to slow it down. Action, they're pushing one direction. Reaction, the ship slows down in the other direction. Finally, there's a really cool part. This, when you look at the habitat pictures in the movie, this picture was drawn from the part where he's showing off his crops to Earth and he's leaning up against an imaginary pedestal there. He's got his, this is just before the hab breaches, he's got his potato plants. If you look at the heads-up display, they do a really good job with their heads-up display. This is like the Iron Man heads-up display and showing constantly what's going on in the habitat. The oxygen levels, they're always hovering around 20%. In other words, they're mirroring Earth. It looks like Earth there. About 20% oxygen in his atmosphere. They also show the temperature all the time. It looks by the time we get about halfway through the 21st century that we are finally using Celsius because they always have Celsius on there, which is awesome. And finally, one of the little things that's fun to kind of throw in, and I'll use my coffee cup, and speaking of Star Wars, a Star Wars bucket as an example. Empty bucket right here. My coffee cup right now is filled with water, and I'm going to throw water in the coffee cup. One of the things you see in the movie is on the Hermes, on the spaceship, the actors playing, the astronauts are supposed to be standing there, but you're like, wait a second, how do they have gravity on the ship? In the center part of the ship, it shows them kind of floating through. The ship looks like this, looks like a big hub. And you can create a force that acts like gravity. It's called centripetal force. There's centrifugal force, which is center fleeing, and centripetal force. And it's a little bit like taking the water